Welcome to This Explainer. Today, we're looking at something that absolutely feels like it belongs in a movie theater, but is actually unfolding right now in robotics labs and factory floors across the globe. We're examining the sudden, frankly massive explosion of humanoid robots. And listen, we aren't framing this as science fiction anymore. Based on the hard data and the sheer scale of current investment we're seeing, we really need to start looking at humanoid robots as humanity's next major computing platform. Just let the weight of that statement sink in for a second. In the exact same way the personal computer or the smartphone fundamentally changed how we interact with information, these machines are poised to completely change how we interact with the physical world.
Okay, let's dive right into this. For decades, humanoids were mostly relegated to sci-fi, or at best, they were incredibly clunky academic prototypes that could barely walk across an empty room without, falling over. But contrast that with today. We are witnessing a multi-billion-dollar and potentially trillion-dollar race. The world's biggest tech giants, combined with just a massive influx of venture capital, are pouring unprecedented wealth into this highly specific form factor right now. We're talking about a monumental shift here, moving from historically failed attempts to a modern, highly capitalized industrial arms race.
Which really brings us to a central mystery, and honestly, perhaps the most fascinating part of this entire technological leap. Why are we suddenly trying to build machines that look and move exactly like us? I mean, for years, engineers successfully built robots with wheels, treads, or stationary robotic arms bolted to assembly lines. So why the sudden, overwhelming obsession with 2 legs, a torso, and 2 arms? Well, I'm going to plant a seed for you right now. The breakthrough that's making this possible isn't just about the mechanics of the physical titanium body itself. It's actually about something completely invisible.
So, here is our roadmap for this explainer. First, we'll look at a world built for humans to understand the form factor. Second, the AI brain breakthrough driving this revolution. Third, factories over front doors to see where these machines will actually deploy first. Fourth, we'll ground the hype by looking at the friction and challenges. And finally, we'll explore the economic horizon.
Section 1. A world built for humans.
The form factor.
So, companies like Tesla, with their Optimus program, Boston Dynamics, Figure AI, they are absolutely obsessed with the human form factor. But why? If you want to move heavy boxes in a warehouse, why not just build a really smart forklift, right? Why go through the incredibly difficult physics problem of balancing a heavy metal torso on 2 bipedal legs? Well, the crucial point is this. It is fundamentally cheaper to build a robot that fits our world than to rebuild our entire world for robots. Imagine a major logistics company wanting to automate a massive multi-level fulfillment center. If they rely on wheeled robots, they might have to spend upwards of $50 million retrofitting just one single warehouse. We're talking about widening narrow aisles, building elaborate ramps, completely tearing out the existing infrastructure. It's just not practical.
Think about factories, warehouses, homes, and our existing infrastructure. Our entire physical world is completely 100% biased toward the human body. The height of a door handle, the exact steepness of a staircase, the width of a catwalk, and the ergonomic shape of every single hand tool ever manufactured. A power drill, a screwdriver, a wrench, they are all sized precisely for a human hand. So if you build a humanoid robot, it can seamlessly integrate into these spaces on day one. It can step over loose cables on a factory floor, climb standard industrial stairs, and pick up the exact same tools a human worker uses without requiring any massive, expensive environmental redesigns.
Section 2. The AI brain breakthrough. The invisible engine.
Now, having a robot shaped like a human is completely useless if it doesn't know how to act like one. In the past, the old approach meant engineers relied on highly specialized, hard-coded programming. They had to literally code a robot's every single joint movement for a highly specific, rigid task in a perfectly controlled environment. If a box was accidentally bumped 2 inches to the left, that old robot would just blindly grasp at empty air. But today, thanks to large language models and advanced AI reasoning, these machines have been given an actual brain. Using vision language action models, which is the exact same underlying architecture behind things like ChatGPT, the robot can look at a messy workstation, reason that, oh, the wrench is hidden behind the box, and dynamically adapt its movements on the fly to retrieve it. They don't follow a script anymore. They observe, reason, and act. It's a total game changer.
And this AI software revolution perfectly collided with massive leaps in hardware. But this is where edge computing becomes critically important. A humanoid robot cannot rely on a cloud server to keep its balance. Latency is the absolute enemy of bipedal movement. A robot cannot wait 100 milliseconds for a signal to bounce to a server in Virginia and back just to decide if it's tipping over. It needs powerful, miniaturized GPUs right inside its own head to process massive amounts of visual and physical data instantly. Add in high-density batteries that provide hours of stamina and mass-produced actuators acting as powerful artificial muscles, and you finally have the physical vessel capable of housing this new intelligence.
To actually navigate these complex human environments, these robots use something called SLAM. That stands for Simultaneous Localization and Mapping. Think of SLAM kind of like walking into a completely pitch-black room with a flashlight. As you sweep the beam around, you are simultaneously mapping out the layout of the furniture while concurrently figuring out exactly where you are standing in relation to that furniture. By using highly sensitive cameras and LiDAR, which actually bounces lasers off objects to measure precise distance, the robot sees its surroundings in real time, instantly understanding depth, dynamic obstacles, and the exact 3D geometry of its environment.
So, when a humanoid robot goes to simply pick up a box, it's executing this breathtaking computational ballet. First, it senses the environment. Second, the AI plans the optimal motion. Third, it recalculates its center of gravity and adjusts its balance hundreds of times a second so it doesn't fall forward when it extends its heavy metal arms. And fourth, it applies reinforcement learning. It learns through constant trial and error, analyzing the physics of what worked and what didn't, literally getting permanently smarter with every single interaction.
Now, you might be wondering, if they learn by trial and error, aren't they just constantly destroying expensive parts in the lab? Enter digital twins. A digital twin is a highly accurate, physics-based virtual simulation of the real world. Before a physical robot ever takes a single step on a real factory floor, its AI brain practices in these virtual worlds millions of times. It falls flat on its face, it drops boxes, and it fails spectacularly at the speed of light, all without costing a single dime in broken physical hardware. Once the AI masters the task in the virtual world, that brain is downloaded into the physical robot, which can then perform the task perfectly on its very first try. Pretty incredible, right? But as we're about to see, getting them to walk isn't even the hardest part.
Let's move to Section 3, Factories over Front Doors, Real-World Deployment. Because while the internet is flooded with CGI concepts of robotic butlers making us breakfast and folding our laundry, we really need to separate the sci-fi from the industrial reality of where these machines will actually go to work first.
We're seeing billions of dollars in venture capital flooding into robotics startups right now. And if you follow the money, it is strictly aimed at enterprise and industrial solutions. Why? Because the return on investment math is incredibly simple. Trying to sell a $50,000 robot to a middle-class family to fold their laundry, that is a terrible business model. But selling a $50,000 robot to a multi-billion-dollar logistics company, a robot that can work 24/7 without a break, doesn't get injured, and perfectly integrates into their existing human infrastructure, that enterprise math scales beautifully. They are building industrial workers here, not household companions.
The first wave of humanoid adoption is being fiercely driven by 5 key sectors: manufacturing, warehousing, logistics, healthcare, and hazardous environments. The businesses in these sectors are facing unprecedented, crippling global labor shortages. Think back to the massive supply chain disruptions we've all experienced recently. A huge part of that bottleneck is simply a lack of human bodies willing or available to do dangerous, repetitive, or physically demanding jobs. Therefore, the gritty industrial sector is going to serve as the actual proving ground for humanity's next computing platform.
Section 4. The Friction and Challenges. Time to ground the hype.
Because look, despite the brilliant AI and the billions invested, there are some brutal engineering hurdles standing directly in the way of widespread adoption. Battery life is a massive bottleneck. Moving heavy metal limbs against gravity while running powerful edge AI drains power incredibly fast. But the most fascinating technical challenge right now is actually dexterity. Replicating the human hand is basically a mechanical nightmare. A human hand has an immensely complex network of tendons, muscles, and tactile nerves. Engineering a robotic hand with the tactile feedback required to tightly grip a heavy, vibrating power drill one moment and then gently pick up a fragile glass light bulb the next, that is incredibly difficult. Add to that the strict safety regulations for heavy machines working alongside fragile humans, the very real threat of cybersecurity hacks, and finally just getting the general public to actually trust these machines.
Section 5. The Economic Horizon. The Future of Work. Assuming these engineering hurdles are cleared, and honestly, the investment data strongly suggests they are being cleared at an exponential rate, we have to zoom out and look at the macro level.
Now, what's really interesting here is the verified data from the International Federation of Robotics. The trajectory is absolutely undeniable. Global industrial robot installations are violently moving upward. And this isn't just a cost-cutting measure anymore. We are facing severe global aging populations. In highly industrialized nations like Japan and Germany, there physically aren't enough young people entering the workforce to replace retiring factory workers. Automation at this advanced, humanoid level is no longer just a luxury to improve profit margins, it is rapidly becoming a structural necessity to keep our global supply chains from collapsing under the weight of demographic collapse.
There's a quote from the source material that perfectly encapsulates everything we've covered today. It says, "The next industrial revolution may not arrive on 4 wheels or conveyor belts. It may walk through the front door." The convergence of artificial intelligence, edge computing, and bipedal robotics means this is an imminent reality. We are looking at a fundamental structural shift in exactly how physical work will be done on this planet.
Which leaves us with this final vital question. The future is arriving faster than ever. Are we ready to work alongside humanity's next computing platform? The science fiction of yesterday is truly becoming the supply chain reality of today. It's going to be completely fascinating to watch how our society, our economics, and our engineering adapt to this new era. Thank you so much for joining me on this explainer, for engaging with this detailed breakdown, and for taking the time to truly understand the incredible mechanics and implications of the humanoid robotics revolution. Keep learning, and I'll see you next time.
Thanks for watching World Decoded. Make sure to like and share, subscribe, and stay curious.